Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in today's video, I am going to discuss the solutions of three mathematics questions that were asked in recently held JEE Advanced 2025 Paper 1 exam. Now this is the first question of this video. This question is based on the topic of limits. It says, let alpha and beta be the real numbers such that limit extending to 0, 1 upon x cube into inside the bracket alpha upon 2 into integral 0 to x dt upon 1 minus t square plus beta into x into cos x bracket close equal to 2, then the value of alpha plus beta is. Now students, the given limit can be written as limit extending to 0. In the numerator we have alpha upon 2 into integral 0 to x dt upon 1 minus t square plus beta into x into cos x. And in the denominator we have x cube. And this limit is equal to 2. Now students, if I put x equal to 0 both in numerator and denominator, clearly we will get 0 by 0 form. Now since the functions coming in the numerator as well as in the denominator are differentiable functions with respect to x and the limit is of the form 0 by 0, so we can apply L'Hospital's rule. Now students, when we apply L'Hospital's rule to the above limit, it becomes limit extending to 0. In the numerator, when we differentiate this definite integral, we will use Newton-Leibniz rule of differentiation of definite integrals. So now it becomes alpha upon 2 into the derivative of x is 1 into it is 1 upon 1 minus x square. Bracket closed, and then we have plus beta into. Now to differentiate x into cos x, you can use product rule. So it is cos x minus x into sin x. And in the denominator, we have 3x square. And this limit is equal to 2. Now students, we move further. Now students, the value of this limit is a finite number. And when we put x equal to 0 in the denominator, it approaches 0. So this means the numerator must also approach 0 when x tends to 0. And this is possible only when alpha upon 2 plus beta is equal to 0. This implies alpha plus 2 beta equal to 0. Now this is the first equation in terms of alpha and beta. Now students, we will again apply L'Hospital's rule to the above limit. Now it becomes limit extending to 0 alpha upon 2 into 2x upon 1 minus x square whole square plus beta into inside the bracket minus sin x minus x cos x. Bracket closed, whole divided upon 6x. And the value of this limit is 2. Now students, on the left hand side, we can easily find the value of this limit by separating the terms of numerator and dividing them by 6x. Now this is limit extending to 0. I can write alpha into x divided upon 1 minus x square whole square into 6x. Then plus into beta into inside the bracket minus 2 sin x whole divided by 6x, and then we can write minus beta x into cos x whole divided upon 6x, and the value of this limit is 2. Now students, clearly this x cancels with this x cancels with this x, and now when we put x as 0 in the first part of this limit, it becomes alpha upon 6, and we know that sin x upon x when x tends to 0 is nothing but 1. So the middle part of this limit becomes minus beta upon 3, and when x tends to 0, clearly cos x approaches 1. So the value of the last part of this limit is minus beta upon 6, and this value is further equal to 2. Now students, when I multiply the whole equation by 6, I get alpha minus 2 beta minus beta equal to 12. So this implies alpha minus 3 beta equal to 12. Now this is the second equation that we have got in terms of alpha and beta. Now students, we will solve the equation number 1 and equation number 2 mutually to get the values of alpha and beta. Now students, when I subtract the second equation from the first equation, I get 5 beta equal to minus 12. So this means beta is equal to minus 12 upon 5. And since alpha is equal to minus 2 beta, so the value of alpha becomes 24 upon 5. Now students, we have to find the value of alpha plus beta. So it is clearly 24 minus 12 divided upon 5, which is 12 upon 5. And this is 2.40. So 2.40 is the correct answer of this question. Now students, we move towards the next question. Now students, this is the next question. This question involves the concepts of functional equation and sequences and series. It says, let capital R denote the set of all real numbers. Let fr to r be a function such that f of x greater than 0 for all x belonging to capital R, and f of x plus y equal to f of x into f of y for all x comma y belonging to capital R. Let the real numbers a1 comma a2 and so on till a50 be in an arithmetic progression if f of a31 equal to 64 into f of a25 and summation I varying from 1 to 50 f of ai equal to 3 into inside the bracket 2 to the power 25 plus 1, then the value of summation of f of ai, where I is varying from 6 to 30, is. Now students, to solve this problem, first of all, you must know whenever you have this type of functional equation where f of x is greater than 0 for all real values of x and f of x plus y is equal to f of x into f of y for all x comma y belonging to capital R, then the function f of x is given by k to the power x, right? So this means f of a31 will be equal to k to the power a31, and similarly f of a25 will be equal to k to the power a25. Now students, we have been given that a1, a2 and so on till a50 are in an arithmetic progression. So that means I can write a25 equal to a1 plus 24 into d, where d is the common difference of this ap, and similarly a31 will be equal to a1 plus 30 into d. Now students, we have been given this particular relation between f of a31 and f of a25. So according to this, I can write k to the power a31 equal to 64 into k to the power a25. Now it becomes k to the power a1 plus 30d equal to 64 into k to the power a1 plus 24d. Now from here k to the power a1 can be separated into, I can write k to the power 30d, and this is equal to 64 into, again k to the power a1 can be separated into k to the power 24d. Now students, clearly k to the power a1 gets cancelled on both the sides, and from here I can write k to the power 6d equal to 64. So this means 6d is equal to log of 64 to the base k, and from here I can write d equal to log 2 to the base k. Why? Because 64 is 2 to the power 6, and according to the law of logarithm, log m to the power p can be written as p into log m. So this means log of 64 to the base k can be written as 6 into log 2 to the base k, and 6 will get cancelled on both the sides, so we will get d equal to log 2 to the base k. Now students, we move further. Now students, we are given that summation I varying from 1 to 50 f of ai equal to 3 into, inside the bracket, 2 to the power 25 plus 1. Now this summation can further be written as f of a1 plus f of a2 plus f of a3 and so on till f of a50. And this is equal to 3 into, inside the bracket, 2 to the power 25 plus 1. Now students, since f of x is equal to k to the power x, so f of a1 will be equal to k to the power a1, and a2 can be written as a1 plus d. So this means f of a2 will become k to the power a1 plus d, and similarly f of a3 will be k to the power a1 plus 2d, plus and so on till the last term, and the last term is k to the power a1 plus 49d, and this is equal to 3 into, inside the bracket, 2 to the power 25 plus 1. Now students, I am taking out k to the power a1 common, and inside the bracket we will have 1 plus k to the power d plus k to the power 2d plus k to the power 3d and so on till k to the power 49d, and this is equal to 3 into, inside the bracket, 2 to the power 25 plus 1. Now students, this can further be written as k to the power a1 into, inside the bracket, 1 plus. Now students, we have just found the value of d as log 2 to the base k. So this means k to the power d will be equal to 2. And k to the power 2d will become 2 square. K to the power 3d will be 2 cube, and so on till 2 to the power 49. And this is equal to 3 into, inside the bracket, 2 to the power 25 plus 1. Now students, on the left hand side, inside the bracket, we are having a geometric progression. We will find its sum and get the value of a1. Now we move further. Now students, it further becomes k to the power a1 into inside the bracket. To find the sum of these terms, just apply the formula of sum of n terms of GP. Here the value of n is 50, the value of common ratio is 2, and the first term is 1. So it becomes 1 into 2 to the power 50 minus 1 whole divided upon 2 minus 1. And this is equal to 3 into inside the bracket 2 to the power 25 plus 1. Now it further becomes k to the power a1 into inside the bracket 2 to the power 50 minus 1, and on the right hand side we have 3 into 2 to the power 25 plus 1. Now students, 2 to the power 50 minus 1 can further be written as 2 to the power 25 whole square minus 1 square, and then by applying the identity of a square minus b square equal to a minus b into a plus b, we can factorize it. So now it becomes k to the power a1 into 2 to the power 25 minus 1 into 2 to the power 25 plus 1. And on the right hand side we have 3 into inside the bracket 2 to the power 25 plus 1. Now students, clearly the term 2 to the power 25 plus 1 gets cancelled on both the sides, and we get k to the power a1 equal to 3 upon 2 to the power 25 minus 1. Now students, if you want to get the value of a1, you can take log on both the sides and get the value of a1. Although in further calculations, we will directly use the value of k to the power a1. Value of a1 is not separately required. So I am just writing the value of a1 as log of 3 upon 2 to the power 25 minus 1 to the base k. Now students, we move further. Now students, we have to find the value of summation I varying from 6 to 30 f of ai. So that means we have to find the value of f of a6 plus f of a7 plus f of a8 and so on till f of a30. Right? Now students, f of a6 is k to the power a6. F of a7 is k to the power a7 and so on till plus k to the power a30. Now students, a6 can be written as a1 plus 5d. And a7 can be written as a1 plus 6d. And similarly, a30 can be written as a1 plus 29d. So that means if I take out k to the power a1 common inside the bracket, I will get k to the power 5d plus k to the power 6d and so on till k to the power 29d. Now students, this becomes k to the power a1 into inside the bracket. We know that k to the power d is equal to 2. So k to the power 5d will become 2 to the power 5. K to the power 6d will become 2 to the power 6 and so on till k to the power 29d will become 2 to the power 29. Now inside the bracket again we are having a geometric progression. We will find its sum and put the value of k to the power a1, and finally we will get the answer of this question. Now students, it further becomes equal to, just put the value of k to the power a1. It is 3 upon 2 to the power 25 minus 1 into, inside the bracket, now we have to use the formula of sum of n terms of GP. Here the total number of terms is 25. The first term is 2 to the power 5 and common ratio is 2. So it becomes 2 to the power 5 into 2 to the power 25 minus 1 whole divided upon 2 minus 1. So now this further becomes 3 upon 2 to the power 25 minus 1 into 2 to the power 5 is 32 into, inside the bracket we have 2 to the power 25 minus 1 whole divided by 1. Now students, clearly the term 2 to the power 25 minus 1 gets cancelled and final answer is 96. So this is the correct answer of this question. Now students, we move towards the last question of this video. Now students, this is the last question of this video. This question involves the concepts of differential equations and limits. It says, for all x greater than 0, let y1x, y2x, y3x be the functions satisfying dy1 upon dx minus sin x whole square into y1 equal to 0, where y1 at x equal to 1 is equal to 5. dy2 upon dx minus cos x whole square into y2 equal to 0, where y2 at x equal to 1 is equal to 1 upon 3. dy3 upon dx minus, inside the bracket, 2 minus x cube whole divided upon x cube into, outside the bracket, y3 equal to 0, where y3 at x equal to 1 is equal to 3 upon 5e respectively. Then limit x tending to 0 plus y1x into y2x into y3x plus 2x whole divided upon e to the power 3x into sin x is equal to. Now students, we can solve this question in two different ways. The first method is, you can solve these differential equations and get the functions y1x, y2x and y3x, and then you can put these functions into this limit and find the value of this limit. And the another method is, we can directly find the product of these functions without finding these functions separately, and then we will use this product in this limit and find the value of this limit. Now I am using the second method because it will make the calculations easier. Now students, I am starting with the first differential equation. Now the first differential equation can be written as dy1 upon y1 equal to sin x whole square into dx. Now clearly it is a variable separable form of differential equation. Now just integrate both sides and now we get ln y1 equal to integral of sin square x dx. Now students, I am calling this particular equation as equation number 1. Now we move further. Now students, the second differential equation can be written as dy2 upon y2 equal to cos square x into dx. Now when we integrate both sides, we get ln y2 equal to integral of cos square x dx. I am calling this equation as equation number 2. Now we take the third differential equation. It can be written as dy3 upon y3 equal to 2 minus x cube whole divided upon x cube into dx. And when we integrate both sides of this equation, we get ln by 3 equal to integral of 2 upon x cube minus 1 dx. I am calling this equation as equation number 3. Now students, we will add all the three equations. When we add them, we get ln by 1 plus ln by 2 plus ln by 3. And by using the property of logarithm, we can write this as ln of y1 into y2 into y3. This is equal to integral of sine square x plus cos square x plus 2 upon x cube minus 1 dx. Now students, we move further. Now students, we get ln of y1 into y2 into y3 equal to integral of sine square x plus cos square x, which is 1, plus 2 upon x cube minus 1 into dx. Now clearly 1 cancels with minus 1 and we get integral of 2 upon x cube dx. Now this is x to the power minus 2 upon minus 2 into 2, which is further equal to x to the power minus 2 divided upon minus 1 plus c. Now students, we can write ln of y1 into y2 into y3 equal to c minus 1 upon x square, where c is a constant. Now from here I can write y1 into y2 into y3 equal to e to the power c minus 1 upon x square. Now this can further be written as e to the power c into e to the power minus 1 upon x square, and we can replace e to the power c by k. So this becomes k into e to the power minus 1 upon x square. Now students, in this question, we have been given the values of y1, y2 and y3 all at x equal to 1. So now we will put x equal to 1 on both sides of this equation. Now the value of y1 at x equal to 1 is given as 5. Value of y2 at x equal to 1 is given as 1 upon 3. And value of y3 at x equal to 1 is given as 3 upon 5e. And on the right hand side we have k into e to the power minus 1, which is actually k upon e. Now e gets cancelled on both the sides and finally we get k equal to 1. So now I can write y1 into y2 into y3 equal to e to the power minus 1 upon x square. Now students, we will use this product in the limit and find the value of the limit. Now students, the given limit becomes limit extending to 0 plus. In place of y1 into y2 into y3, just put e to the power minus 1 upon x square. And then we have plus 2x whole divided upon e to the power 3x into sine x. Now this can further be written as limit extending to 0 plus 1 upon e to the power 3x into limit extending to 0 plus e to the power minus 1 upon x square plus 2x whole divided upon sine x. Now students, we know that when x approaches 0, then 1 upon e to the power 3x will approach 1. So this means this limit becomes limit extending to 0 plus e to the power minus 1 upon x square plus 2x whole divided upon Now sin x can be written as sin x into x whole divided upon x. And now this limit becomes limit extending to 0 plus x upon sin x into limit extending to 0 plus e to the power minus 1 upon x square plus 2x whole divided upon x. Now students, when x tends to 0 plus, then x upon sin x will approach 1. So that means now it can further be written as limit extending to 0 plus e to the power minus 1 upon x square whole divided upon x plus 2. And now this can be written as 2 plus limit extending to 0 plus. Now students, e to the power minus 1 upon x square is actually 1 upon e to the power 1 upon x square. So now this expression becomes 1 upon x whole divided upon e to the power 1 upon x square. And now at this stage, I can put t equal to 1 upon x. Now since x is approaching 0, so t will approach infinity. And now this becomes 2 plus limit t tending to infinity t upon e to the power t square. Now students, when t approaches infinity, then t square also approaches infinity and e to the power t square will also approach infinity. So that means now this limit becomes of the form infinity by infinity. And now we can apply L'Hospital's rule. So this becomes 2 plus limit t tending to infinity 1 upon 2t into e to the power t square. Now clearly, when t approaches infinity, then this limit will become of the form 1 upon infinity, which is actually 0. So that means the value of this limit is 2 plus 0 or equal to 2. Now students, I have created two separate playlists of paper 1 and paper 2 for JEE Advanced 2025 maths paper solutions. So you can just go to the playlist section of my channel and watch all of these videos. Keep watching my videos and enhance your knowledge of mathematics. Thanks.